Good morning or good afternoon, everyone. I'm sorry that I can't be with you here today, but I have left notes for solving one-step inequalities. We're going to start with our essential question: how do we solve one-step inequalities? So a little bit of a review from Friday. Remember that when you graph inequalities, whenever your answer cannot be exactly equal to a number, we use an open circle, and that corresponds with either greater than or less than. And when your answer can be exactly that number, we are talking greater than or equal to, or less than or equal to. Now, when you solve an inequality, you solve it the same way that you would solve an equation. But we do have a special rule, and we'll get into that a few slides from now. So starting with number 1, m plus 4 is greater than 9. Now I know some of you might be able to do this in your heads, however we do need to learn how to use the proper notation and the proper algebra. So all of the inequalities we are working with today are one step. So in this particular inequality, I see m plus 4. So the operation that we see is adding. I undo adding with subtracting, and I have to make sure that I do it to both sides. So subtracting 4 from both sides, 4 minus 4 cancels out. I am left just with m is greater than, and 9 minus 4 is equal to 5. So the solution to this inequality is m is greater than 5. So based on that inequality, m cannot be exactly equal to 5, so I will have an open circle at the 5, and greater than means the arrow will point to the right. So my solution is m is greater than 5, and we have graphed it as well. For problem number 2, we see x minus 8 is less than or equal to negative 12. So the operation I see here is subtraction. I undo subtraction with addition to both sides. So the negative 8 plus 8 cancels out, and all that I am left with on the left-hand side is x is less than or equal to, and negative 12 plus 8 is negative 4. So graphing this problem, x is less than or equal to. It could be exactly negative 4, so I'm going to have a colored in dot at negative 4, and less than points to the left. Okay, looking at number 3, k plus a negative 5. Well, don't forget that k plus negative 5 can be written just as k minus 5 is less than 1. So for this problem, we are actually just subtracting 5, and I undo subtracting 5 by adding 5 to both sides. So negative 5 plus 5 on the left-hand side cancels out. All I'm left with is the k is less than, and 1 plus 5 is 6. So k is less than 6. Well, that means k cannot be exactly equal to 6, so I will have an open circle at 6, and less than points to the left. Now, earlier in the video, I told you guys that we have a special rule. If you look at the left-hand side of your notes, you see it says special rule. So I would like you to copy this down in that section. Our special rule for inequalities. Consider the inequality 2 is greater than negative 2. Now I want us, so now multiply both sides by negative 1. So I'm going to rewrite this. So 2 is greater than negative 2, and I'm going to multiply both sides by negative 1. I can do this because I'm doing it to both sides of the inequality. I'm keeping it balanced. So negative 1 times 2 is negative 2, and negative 2 times negative 1 is positive 2. Is this inequality true? Negative 2 is greater than 2. Well, no, of course that's not true. We need to change the inequality sign. So we need to flip-flop it, if you remember from Friday. Negative 2 is greater than 2. So I'm going to go back a couple slides here. At this spot in your notes, I want you to copy down when we multiply, or divide, by a negative number, we must flip-flop the inequality symbol. So example 4 is going to be an example of our special rule. Oh, excuse me, actually, it's not. I was getting a little bit ahead of myself. We'll see some examples of our special rule on the back side of our notes, actually. But I do want to bring up our special rule because a lot of times students see this negative 20 and assume that we need to apply our special rule. And to be quite honest, I tricked myself into thinking that too. But all that matters is the number we're going to divide by is positive. So 5 times m, I undo that by dividing by 5. And again, I'm dividing by a positive 5. So my special rule does not apply yet. So the 5's cancel out. All we're left with on the left-hand side is m is greater than or equal to, and negative 20 divided by 5 is negative 4. So if I was going to graph this, m is greater than or equal to negative 4. Since it can be exactly equal to negative 4, I will have a closed circle at negative 4, and the arrow will point to the right for greater than. Now on problem 5, this is a special rule problem. And no, I did not make a mistake this time. This is a special rule problem. P divided by negative 2 is greater than 3. So I'm going to recopy this just to give myself some space to show my work. Okay, so we're dividing here. P divided by negative 2. So to undo dividing, I need to multiply both sides by negative 2. So the 2's cancel. Negative 2 divided by negative 2 is 1. On this side, we're left with P. But since I multiplied by a negative number, I have to follow my special rule and flip-flop the inequality sign. So P is less than negative 6. And I'm going to make a special note here. I want you to do this on your paper, that this was a special rule problem. Now, to graph it, P is less than negative 6. It cannot be exactly equal to negative 6, so we'll have an open circle at negative 6, and for less than, the arrow points to the left. Problem number 6, x minus 3 is less than or equal to negative 5. I undo subtracting by adding. But I'm going to get the blue ink here. I'm going to add 3 to both sides. So the 3's cancel. I'm left with just x is less than or equal to, and negative 5 plus 3 is negative 2. So x is less than or equal to negative 2. It can be exactly negative 2. So I will have a closed circle, a colored in circle at negative 2, and the arrow points to the left for less than. Okay, so number 7, negative 7m is less than 28. So I undo multiplication with division. I'm going to divide both sides by negative 7, but if I'm dividing by a negative number, this is a special rule problem. And please make sure you write down special rule so you don't forget. Negative 7 divided by negative 7 cancels. We're left with m, and because it's a special rule problem, I need to flip-flop the inequality, so it becomes m is greater than, and 28 divided by negative 7 is negative 4, so it cannot be exactly negative 4. There's going to be an and negative. Make sure that you graph this at negative 4. An open circle at negative 4, and greater than would be to the right. Okay, number 8. To get an A, you need more than 200 points on a 2-part test. You score 109 points on the first part. How many more points do you need? We need to write and solve an inequality. Now, one of the first things that I notice is this phrase more than, and more than is going to suggest greater than. Now, ask yourself, what if you get exactly 200 points on the test? Will you get an A? Well, it says we need more than 200 points, and since exactly 200 is not more than 200, we're not going to use greater than or equal to, we're just going to use greater than. So, first thing you need to do is to define a variable. I'm going to just choose S to be the score on the 2-part test. So let's start with S. If we add our 109 points to that, we need it to be greater than 200 points. So to solve this inequality, S plus 109, we would subtract 109 from each side. On the left-hand side, that cancels out, and we're just left with S is greater than 200 minus 109 would be 91. So what this tells me is that I need more than 91 points to get an A. Alright, so now you should be working on the Solving One-Step Inequalities worksheet. It is due tomorrow. And don't forget, your Unit 2 test is on Friday. If you think you're still having trouble, especially with the algebra, please either leave a note with the sub or talk to me tomorrow about coming in for some extra help. Tomorrow we'll be talking about 2-step inequalities, and then we will spend Wednesday and Thursday reviewing for the test on Friday. So I hope you guys have a great day. Please make sure that you are remaining in your seats and you are getting your work done, and I will see you tomorrow.